Hello, in this video we are finishing up our discussion of section 7.4 on arc length by working through example 3, which says to set up but do not evaluate the integral that gives the length of the curve y equals x squared from x equals 0 to x equals 1, and it asks what integration technique would be used to evaluate the integral. So let's first off set up the integral and then see what it looks like before we answer our question about what integration technique would be used. So finding y prime, we get that it's equal to 2x, which is definitely continuous everywhere. So we are fine there. So this means that the length is going to be the integral from 0 to 1 of the square root of 1 plus 2x squared dx. So there's our length integral. Then to answer the question of what integration technique, well, we could try squaring that out. We would get 1 plus 4x squared. U substitution isn't going to work there like it did in example 1 because this is a bit too complicated. If we took u being 1 plus 4x squared, du is going to be 8x dx, and that x gives us an issue. But if you look back here at what we have before we squared out the 2x, that looks pretty similar to something that would work for a trig substitution. If we were going to do a trig substitution here, we have a constant squared plus a function of x being squared. So this means that we're going to need to use a tangent function. Our a value is just 1, and we have a 2x instead of x. So we could use a trig sub here. Our substitution would be 2x equals 1 times tangent of theta, and then you could go from there. But as far as this problem goes, all it asks for is the integration technique. So you could just leave it with trig sub, and that is the only one that would work in this case. I recommend that you try to work through this for practice with trig substitution. Try to work through this with 2x being tangent of theta and see if you can get a final answer.